In April 2026, the Air Force shocked the defense world by extending the 50-year-old A-10 Warthog's service life to 2030. The Air Force had planned to retire all 162 remaining A-10s, but instead restarted the wing replacement program, installing brand new heavy-duty wings designed to add another 10,000 flight hours. That decision makes one thing clear. The A-10 still performs a mission. The $100 million F-35 cannot perform economically. The F-35 is faster, stealthier, and far more advanced. But when the target is a convoy, artillery position, supply truck, or exposed ground force, the Warthog brings something the F-35 cannot match: armor, endurance, and 65 rounds per second of cannon fire. The F-35 was supposed to replace the A-10. But in sustained ground combat, the F-35 may be too expensive to win the war by itself. Here's exactly how. The A-10 costs approximately $20,000 per flight hour. That is less than half the F-35's estimated operating cost of approximately $42,000 per hour. But the real advantage is not only the hourly price, it is the way the aircraft was designed to absorb damage and continue the mission. The A-10 uses triple redundant flight systems. If the hydraulics fail, the pilot can still control the aircraft using manual cables and pulleys. Its two General Electric TF-34GE100 engines are positioned separately from the fuselage, reducing the chance that one hit destroys the entire aircraft. The pilot sits inside a 1,200-pound titanium cockpit known as the titanium bathtub. In some areas, the armor is up to 1.5 inches thick and is designed to withstand direct point-blank hits from 23mm, armor-piercing, and high-explosive anti-aircraft rounds. The cockpit is also lined with multi-layer ballistic nylon to catch fragments and spalling after an impact. That does not make the A-10 invincible. It makes the aircraft more tolerant of damage than a platform built around avoiding detection entirely. Then there is the GAU-8/A Avenger. The cannon, ammunition feed system, and loaded drum weigh 4,029 pounds, or 1,828 kilograms. The complete system is 19 feet and 5.5 inches long, while the ammunition drum is almost 3 feet wide and nearly 6 feet long. The cannon fires 3,900 rounds per minute. That equals 65 rounds every second. Each standard armor-piercing round leaves the barrel at 3,324 feet per second, or 1,013 meters per second, well over Mach 3. Each round carries more than 200,000 joules of muzzle energy. The average recoil reaches 10,000 pounds, or approximately 45 kilonewtons. That is more force than one TF-34 engine produces in forward thrust. Each engine generates approximately 9,065 pounds of thrust, which is why the cannon is mounted slightly off-center to reduce the effect of recoil on the aircraft's flight path. The A-10 is not an aircraft carrying a cannon. The aircraft was built around the cannon. The F-35 is better at missions the A-10 cannot perform. The baseline flyaway cost of an F-35A is approximately $82.5 million. Once weapons, logistics, specialized equipment, and pilot training are included, the total cost easily passes $100 million per aircraft. The F-35 burns approximately 1,350 gallons of fuel every hour. Depending on fuel prices, that represents roughly $5,000 to $7,000 in fuel alone. For every hour the F-35 spends in the air, it can require up to 30 hours of delicate maintenance. That cost is justified when the F-35 is penetrating hostile airspace, attacking radar systems, hunting command centers, or opening a path through an advanced air defense network. But the economics change when the target is a convoy or artillery position. The F-35 may need a precision-guided weapon, costing hundreds of thousands or even millions of dollars to destroy a single ground target. The A-10 can attack vehicles, artillery, exposed troops, and supply equipment repeatedly without using a strategic weapon every time a truck appears. The F-35 is built around avoiding detection. The A-10 is built around surviving detection. The F-35 tries to prevent the enemy from getting a shot. The A-10 is designed to keep flying after the shot has already landed. That is the difference between penetrating the battlefield and remaining over it. The most important part of this argument is not the original A-10. It is the modernized A-10C. The A-10C adds improved targeting systems, precision-guided weapons, digital communications, and modern battlefield networking. This is the difference between an old aircraft and an old airframe carrying modern information. The A-10C is not a museum aircraft. It is a networked attack platform. The proposed 2026 Super Warthog concept takes that idea further. Instead of operating as a simple attack aircraft, the upgraded A-10 could act as a heavily armored flying command node, coordinating a localized swarm of up to 500 artificial intelligence kamikaze drones. That would give the Warthog a way to attack targets without using its own ammunition for every engagement. It could identify threats, direct drones, support ground forces, and continue operating near the battlefield, while the unmanned swarm attacks deeper targets. The proposed upgrade also includes high-velocity smart rounds for the 30mm cannon. The projected cost is approximately $100 per shell, while a precision strike against a similar target can cost approximately $2 million. That is a 20,000 to 1 difference. The upgraded aircraft could also carry advanced laser-guided rockets and improved AGM-65 Maverick missiles. The exact performance would depend on the final weapons load, sensors, and mission profile, but the purpose is clear. He creates sustained firepower at a fraction of the cost of using an F-35 for every ground target. The F-35 opens the door. The upgraded A-10 destroys what is behind it. The A-10 cannot operate alone against China or Russia. Russia's Su-25 demonstrates why. The Su-25 was built around a similar concept. Fly close to the battlefield, attack ground forces, absorb damage, and support troops near the front line. But the war in Ukraine exposed the limitations of that design when operating inside a dense, modern air defense environment. Russian Su-25 aircraft have been repeatedly shot down or heavily damaged by shoulder-fired man-portable air defense systems, commonly known as manpads. The aircraft may survive small arms fire and fragments, but armor cannot solve the entire detection problem. A relatively cheap drone costing approximately $2,000 can locate an aircraft, while a low-cost missile costing around $50,000 can destroy a multi-million-dollar platform. A long, loitering attack profile gives the enemy repeated opportunities to detect, track, and engage the aircraft. The A-10's 1,200-pound titanium armor remains valuable, but it is not an invincible force field. Modern air defenses are designed to prevent the aircraft from getting close enough for that armor to matter. Dedicated close air support aircraft therefore require drones, jammers, escorts, and suppression of enemy air defenses before they can operate safely. China presents an even more complex problem. Its military advantage is not based only on the J-20 stealth fighter. It is based on an interconnected system that includes advanced radar arrays, thousands of long-range surface-to-air missiles, maritime surveillance, electronic warfare, and next-generation command and control networks. An A-10 entering that environment as an independent first-wave penetrator would be destroyed by long-range missiles before it reached the close air support phase. The aircraft's low speed, large thermal signature, and requirement to remain near the target area would make it vulnerable to repeated detection. The F-35 would have to open the door first. Its stealth and sensor systems could locate radar nodes, attack air defense batteries, disrupt communications, and blind sections of the network. The F-47 could eventually perform a similar command and control function for drones and autonomous aircraft. Only after that network is degraded could the A-10C enter safely. Its role would be to attack the exposed battlefield forces that remain: logistics vehicles, artillery, fuel storage, ammunition sites, and infantry positions. The technical lesson from both the Su-25 and China's integrated air defense structure is force specialization. The A-10 is not a replacement for stealth penetration aircraft. It is a follow-on platform that requires the battlefield to be prepared before it arrives. The F-35 was supposed to replace the A-10, but the upgraded A-10 may replace the F-35 wherever the mission is no longer about sneaking in, and is only about staying there long enough to destroy everything that keeps moving. The Warthog does not need to be more advanced than the F-35. It needs to be more appropriate. It needs to carry more firepower, stay longer, cost less per attack, and survive the kind of battlefield where a stealth fighter is financially impossible to use against every target. The A-10 is not obsolete. The F-35 may simply be too expensive to fight the entire ground war. That is not an upgrade. That is a replacement. So is the A-10 truly obsolete? Or is the Pentagon trying to replace the one aircraft already built for this battlefield? Drop your theory in the comments. The best theory becomes our next full video.